In this video, we're going to go over the review notes for derivative applications and answer a few problems off one of the review sheets. Basically, for your final, you're going to be expected to be able to write the equation of a tangent line to a function at a given point. We've got the steps there. We'll review them in just a minute. We're going to be dealing with questions involving average rate of change and instantaneous rate of change. We're going to hold off from optimization. Okay, we did not do that yet in this course. And lastly, we're going to look at the curve sketching or curve analysis using calculus when we use the first derivative and the second derivative. Now, we just completed this topic in class, so we're not going to really go into too much detail there because that should really be fresh in your head. Going back to some of the previous material, if we take our review sheet for this topic, okay, I have a few questions that I picked out to do. If we want to write the equation of a tangent line to the graph at a given point. So let's say we're looking at question 2, and we want to write the equation of the tangent line to f of x equals x cubed minus x squared at the point 2, 4. Okay, so remember what we need for every equation of a tangent line. We need the point, we need the slope, and we need to plug it into our point slope form. Well, here we have the point. Our point is 2, 4. If they just gave us the x value, we would take that x value, plug it into our function to get the y value. Now for the slope, we need to find the derivative of this function and then plug x in. So first we're going to find the rule for the derivative. F prime of x equals 3x squared minus 2x. Now when we evaluate, or when we plug 2 into this rule, the answer will be the slope of the tangent line at that point. So this is 12 minus 4. Our slope is going to be 8. Now that we have our point and our slope, we just plug it right into our formula. Y minus y1 equals 8 times x minus x1. You could clean this up. Sometimes some teachers like you to write it like that. That's pretty much, what you want to get in the habit of for next year. Or you could go a step further and put it in mx plus b form. There are a lot of different ways we could write this answer. Okay, so we have our point slope form. This is called linear approximation form. This is our mx plus b form. So I would probably accept that on your final, or that. Okay. The next question. For what point is the tangent to y equals 3x squared minus 5x horizontal? So here, horizontal means the slope of the tangent line is 0. Okay. So when we want to find when the slope of the tangent line is 0, we're going to set the derivative equal to 0. Set that equal to 0, and we get that this is going to be when x equals 5/6. We're going to take this, right? We want a point. They asked us for the points, point or points. So when x is 5/6, we want to get the y value. So we would go back up into the original. Ooh, that's a lot of math there. So I'm going to get out my calculator. 3. Let's see if we can't write this as a fraction, negative 25 over 12. Okay, so that's how we would do a question of that nature. Now, the next two questions are going to do 8 and 9 have to do with average rate of change and instantaneous rate of change. So we're going to go back to this little picture. Whenever we see average rate of change, we want to think we're using 2 points. We're finding the rate of change between 2 points, so we're going to use the slope of the secant line. When we're being asked to find the instantaneous rate of change, we want the rate of change at one specific value. So then we're going to use the slope of the tangent line or the derivative. So if we look at this question here, find the area of a circle. Oh, well, the area of a circle is A of r equals pi r squared. We want the average rate of change between r equals 2 and r equals 3. So we want to set up the formula for the slope of the secant line. Average rate of change is slope of the secant line. So basically we're going to do f of 3, or a of 3, minus a of 2 over 3 minus 2. So now we're going to take our 3 and plug it into the original function. So pi r squared, we get 9 pi minus 4 pi over 1. So our answer is 5 pi. Now, usually when we're dealing with application problems, we're going to have units, but this one didn't really give us any units, so I wouldn't expect you to give them to me on the test. For part B of this question, now we want the instantaneous rate of change. So we want the slope of the tangent line at r equals 2. In other words, we want to find a prime of 2. So the first thing we want to do is find the derivative. A prime of r is going to be 2 pi r. And if we plug 2 into the derivative, 4 pi. So that would be the difference between the average rate of change, the rate of change between two values, and the instantaneous rate of change, the rate of change at one specific value. Okay. A lot of times, when we're dealing with these types of functions, with these types of problems, we're going to be dealing with physics types of problems. So physics types of problems involves like throwing stuff up in the air. And I have my little kind of cheat sheet here. Now this does not represent this function here. This is just a general representation. But basically, if we take any function, s of t, we call that our position function. The x-axis is our time, the y is our height. So if we were to follow the path of a ball, it would sort of go something like that. Okay. Now if you notice here, when we reach the top, that's going to be our maximum value, and that's going to occur when the slope of the tangent line is equal to 0. So we kind of use these ideas or concepts as we move through the problem. Okay, that's a general background for that type of problem. So if we want to find the average velocity, I may not work out this whole problem. If we want to find the average velocity, from t equals 1 to t equals 2, average rate of change, I'm setting up the slope of the secant. So I'm going to have s of 2 minus s of 1 over 2 minus 1. To save time, you guys, you can work out that math, so I would let you handle the math on your own to get your answer. Instantaneous velocity at t equals 3. So instantaneous means I need to take this function, find the derivative, and then I need to plug, because we want to know the rate of change at this specific instant. So we're going to take 3 and plug it in. Now again, for time purposes, you guys, you can do that math on your own. That's not a super hard problem to do. How high will it go? Oh, I just spoke too soon. How high will it go? Oh, well, when will it reach its highest point? Okay, so when will it reach its highest point? Let's go back to our picture for a second. When is it going to reach its highest point? Right, x is time. It's going to reach its highest point when the slope of the tangent line is 0. So what we're going to do here is we need to take and set the derivative of this function, which the derivative is negative 32 t plus 64. So we need to highest point means slope of the tangent line, which means the derivative. So we need to set the derivative equal to 0 and then solve for t. So it's going to reach its highest point when t equals 2. The next part of this question is how high will it go? Well, how high will it go? That's going to be what we get when we plug in 2. Right? If this is when it reaches its highest point, if we plug 2 into the function, that's going to be its highest point. So I would go back and that's going to be what? Negative 64 plus 128, hopefully. And the highest point is going to be 64. Again, I was not given any units, so I'm not going to worry about the units right now. When will it hit the ground? So when is this function, when is the ball going to hit the ground? Oh, it's thundering and lightning out. It's going to hit the ground. Basically, it's going to go up in the air. It's going to hit the ground. This is going to be a root. Okay, so basically, we're going to have to set our function equal to 0 to find when it hits the ground. We go back to the original function. And we're going to set that equal to 0 to find the 2 roots in the function. I'm going to factor this guy, negative 16t, t minus 4. So the 2 roots for this function are t equals 0 and t equals 4. And obviously, t equals 4 is when it's going to hit the ground. The next part of this question asks you the instantaneous velocity when it hits the ground. So now we want instantaneous. We want how fast is this thing going when it hits the ground. So when we want to know how fast something's going, we use the rate of change, the derivative formula. And we want to know how fast it's going when t equals 4. And so this object is traveling at negative 64 units per second, whatever the units are. We're not, again, not going to worry about that too much at this point in time. So negative 64. But how can something be moving negative? Well, basically, when we're dealing with velocity or how fast something's going, whenever the point, the rate of change you're looking for is in the positive direction, your velocity or your rate of change is going to be positive. If you notice here at this point here, when it hits the ground, it's moving in the negative direction. So that's how we can have negative rate of change. Okay, so that was a quick little recap. You can finish up the rest of this ditto. I will mention to you that everything on this ditto is important. There's a nice long problem on the back for you to practice. And please, this is very, very important for success on the final. So long.